But yeah, we start our last section of chapter 3 today. We are in section 1.6, radical equations. Our mission for today is to just solve radical equations. So we're going to solve for x, taking all of the wonderful information we've learned throughout the chapter thus far, and now applying it to help us solve for x. The second idea in this lesson, where we solve equations with rational exponents, that'll be part 2 of our lesson. But for today, we're going to solve radical equations. You can skip this second warm-up problem, but this first one I'd like you to go ahead and pay some kind attention to. I think it'll help you out. Making sure you understood what was on the homework last night. Number 1, we'll see. Make sure all that information went in, and I'll show you the answer to this in just a few moments. Yeah, good job. 12x to the 13/12. Nice job. Yeah, you want to talk to me about it there, Alex?
Yeah.
Let me hear it.
We start off.
You don't have to worry about that part.
Start off by getting a common denominator, and then what you want to do from there?
Talk to me about why you thought to get a common denominator. That's correct. What were you about to do?
I was going to multiply the 4 and the 3, and then I was going to add the exponents together.
Yeah, so you were reassociating the problem, putting the integers together. That's 12. And then the powers of x together. And then you said, yeah, you need a common denominator because you were going to add those exponents together. Nice. All right, keep going. What was your common denominator?
12.
It was. Good work.
And then multiplied.
4 times 3, and you got 12. Good job. And then you...
And then when you multiply, you got to add the exponents, right?
Right.
And 13, 12.
Yes, 4/12 and 9/12 is 13/12. That's great. Perfect. Sounds like we've learned some things in the first couple minutes of class today. Nice job. I like it.
I like my logo.
Okay, so today we use all of these skills to actually go ahead and solve for x. So our lesson starts off when we go to solve the new content with 4 steps. And I would like you to just take a quick moment to jot these down. I'm going to go ahead and read them. Remember, writing your steps down, that's a modality. That's a way your brain is going to acquire the information. All right, so step 1, we isolate the radical expression. Remember the word isolate? If you feel isolated, you feel maybe alone. So to isolate the radical just means to get the radical alone. Little disclaimer, if possible, it's not always possible to isolate a radical expression if there's multiple radical expressions in your equation. So this can be a dodgy creature. But step 1 in general, yeah, we work really hard to try to isolate the radical. Step 2, you eliminate the radical, make it go away. You've probably done this before when you were working with the Pythagorean theorem. You know, if you needed to get the, x squared by itself, you'd square root both sides. Well, that works in reverse. If you want to get rid of a square root, you could square both sides. If you want to get rid of a cube root, you can cube both sides. So that'll be something we practice today. Step 3, you solve for x in the resulting polynomial. Remember, sometimes we're going to end up with a quadratic equation that'll require either the quadratic formula or some factoring. A little AC grouping going to come at you today a little bit. AC bust up B, yep. And then step 4, we check for extraneous solutions. And you're probably like, woman, what is that? Extraneous solutions, that's our vocab term for the day. Root word is extra. It's like a little, kind of like a not nice joke. Because I asked the root word one time, and a kid literally told me the root word for extraneous was aeneas. Yeah. I like laughed. It was pretty funny. That gave me a chuckle. And now every time I teach the word extraneous, I laugh when I think about the root word. The root word I think is extra. It's not aeneas. I don't know what that would be a root word for, but we're not going to talk about that. All right, moving on. Extraneous solutions are just extra solutions sorry. That was a little messy looking. Let me clean that up a little bit. Extra solutions. Extra solutions that do not, shouty caps, work when substituted into the original, shouty caps again, equation. So you don't plug them into your work, you plug them right into the original problem. So these are extra solutions that do not work when they're substituted into the original equation. I take this 4-step wordy process down to 4 words really at the end of the day. I'm going to isolate, I'm going to eliminate, I'm going to solve, I'm going to check. That's like my mantra for the day. Isolate, eliminate, solve, and check. All right, giddy up, kids. Let's do it. My mission today wouldn't be an algebra class if I didn't teach you how to solve for x. So step 1, my mission is to isolate the radical expression. That really doesn't happen in this problem. Like, I don't have to worry about that step. The radical expression itself, the thing that the radical in it, is all by itself. Just so you have an idea of what I'm talking about, if you fast forward a little bit to number 3 and just take a little sneak peek at it, this radical expression, this 2x plus 7 right here, that's not by itself because it has this stupid minus x in the way. So little heads up, when I have to isolate the radical, when I have to get the radical by itself, it's going to have something with it. But here, this radical expression is already all by itself, so step 1 is done. I don't have to worry about it. On to step 2. I eliminate the radical. My mission is to break this x plus 5 out of its little mini prison there. So I need to get rid of the square root. Royce, do you know what to do? Yeah, you got to square both sides, right? The entire side. So over here, it's just a 12 right now, but that side gets a little more involved, in which case we might have to FOIL or distribute a little bit. But yeah, I'm going to break this x plus 5 out of its little jail by squaring both sides. So this square right here gets that square root goners. So x plus 5 is now by itself. And then on the right side, I have 12 squared, which is 12 times 12, which is 144. And then to get x by itself, we're moving into step 3. We isolated, we eliminate, now we solve. So I need to solve that for x. I would just subtract 5 from both sides. And 144 minus 5 is 139. Last step, we check. You could, while the checking is mandatory, you don't always have to show it. Some of you are pretty strong mathematicians in your own right. I just care that you take this 139, and even if you just do it in your head, you plug it in. So I could do that. I'm going to take 139 and plug it in for this x right here. 139 plus 5 is 144. And the principal square root of 144 is positive 12. So this answer works. This answer is correct. So just plug it back into the original, make sure it works. What's funny is that, you know, if this right side, if I would have made this right side here negative 12, we still would have gotten an answer of x equals 139, but it would have been extraneous because the principal square root of 144 is positive 12, not negative 12. So if I would have just typed one more symbol in the equation editor when I was typing this problem, we would have gotten our first extraneous solution. That equation wouldn't have had any real solutions. So yeah, that didn't happen to us this time, so it works. We're good. Questions about the process? I'm just going to do it a couple more times. You'll try a couple on your own. It'll be great. You're going to be amazing. All right. Oh, this guy. So again, step one, we isolate, but the radical expression is already by itself. Like I don't have to do anything to get to isolate the radical expression. So I can go right into eliminating. Does anybody know how to get rid of a cube root?
Cube both sides?
Yeah, you cube both sides. Whew, anybody got a calculator handy? Sure hope so. I don't know what 144 times 12 is. At least my brain doesn't yet. So I broke it out of the house. And then 12 times 12 is 144.
1,728.
Nice, thank you, gentlemen. Good looking out. You are the wind beneath my wings. Alrighty, now you gotta just get that x by itself. So we're in step 3, we solve. So I'm gonna subtract 6 from both sides. And I got x equals 1,722. So plug it back in. 1722 plus 6. 1728, and then the cube root of 728 is 12. So this actually works. Cube roots really don't, I mean, I won't say never, but you really aren't going to get extraneous solutions out of those. So, a little bit of that. It's getting warm in here now. It was 61 when I came in this morning. Even Mr. Jones, the phys ed teacher, was like, I gotta go get a sweater. And for that guy to go to get a sweater, like really, it was cold. That guy wears shorts in like minus 15.
That's crazy.
Yes, that is, I agree. It's cold in here, but now it's getting hot. But this lizard loves a terrarium, so I'm sorry. It's so warm in here. Really like it warm. Okay, so square root of 2x plus 7 minus x equals 2. This is the case where we have to isolate the radical first. You see what's in the way? This minus x right here, can't be there. We got to have the radical expression by itself. Any ideas on how to get rid of that x? Ah, very good. Add it to both sides. Now you have the radical equation by itself. So this is x plus 2 on the right side now. I got to break that 2x plus 7 out of there. So I am going to square both sides. You have to square the entire side. This is the mistake I will see. Most common mistake in the process is coming at us. See this x plus 2 squared? Because we just spent time doing properties of exponents. Y'all are going to want to distribute that 2 in. You can't distribute that 2 when there's a plus or a minus in the parentheses. So I always encourage you, when in doubt, write it out, right? So this will be x plus 2 times x plus 2. You're squaring x plus 2. However, on the right side, mission accomplished, you got 2x plus 7. So I'm now going to go ahead and FOIL that right side. X times x is x squared. Outers is 2x, inners is 2x. If I put those together, I get 4x. 2 times 2 is 4. And what I'm noticing right now is I have a quadratic equation. I know I have a quadratic equation because that goofy 2 there. So I have to go back into my memory with chapter 2 to figure out how to solve that. I would go ahead and get one side equal to 0. And then I would try to do AC bust up B, because it's the fastest, but if it doesn't factor, you can use your quadratic formula. That will always work. So I am going to go ahead and get one side equal to 0 by subtracting 2x and subtracting 7 from both sides. My students will always ask, like, are your tests cumulative? And I'd love to say no to that question. But, like, do you see how, like, our stuff from past chapters, it just comes in. Like, I can't even help it. So, do you have to remember how to factor when a teacher teaches it to you? Yes. Do you have to remember the quadratic formula? Also, yes. Like, We don't teach it because it's fun. We teach it because you need it. Although it is a blast. Do not get me wrong. I thoroughly enjoy it. So we got 4x minus 2x. That is 2x. And then 4 minus 7 is negative 3. Then you could do AC bust up B, right? So factors of negative 3 that make negative 2, or I'm sorry, positive 2. That'd be 3 and negative 1. So maybe now some of you are doing your AC bust up B. So you got x squared plus 3x minus 1x, you know, because we always attach an x to these things. Minus 3. And then you got to group it. Oop. So I'll take an x here. And I'll take a negative 1 out over here. This is all still equal to 0, by the way. So I would take the x plus 3 out, because that's there were twice. We only need it once. And then I have x minus 1 left over. So I factored it. Questions about how I factored it? Oh, what's up, Royce? No, you're good? Okay. And then I'm almost done. Were you going to tell me the answers? Yeah, go ahead.
Set each of them equal to 0, so it's x equals negative 3 and then x.
Yeah, you have to use your 0 product property. Roy said it. You have to set x plus 3 equal to 0 and x minus 1 equal to 0. So if I subtract 3 from both sides, you get negative 3. Add 1 to both sides, you get 1. This, my friends, is the case where we're likely to get an extraneous solution. So it's worth a moment to talk a little bit more deeply about the checking process. I would actually show my check in this case. So the first thing I'm going to do is I'm going to check in my equation the solution x equals negative 3. In doing so, I would be plugging negative 3 in for x in my equation and seeing if it gives me 2. So 2 times negative 3, that's negative 6. Negative 6 plus 7 is 1, and then the square root of 1 is 1. Minus a negative 3, that's plus 3. Does 1 plus 3 equal 2? No. So what we learned there is that that is your extraneous solution. You do have to actually check both of them. So that was me checking x equals negative 3. Now I got to check, I'm going to check x equals 1. So I'm going to plug 1 into my equation, because you can actually get no solutions too. So 2 times 1 plus 7, and then I'm going to subtract 1 and see if that's equal to 2. So 2 times 1 is 2. Yeah, 2 times 1 is 2. Plus 7 is 9. And then the square root of 9 is 3. And then 3 minus 1 is 2. In my head, I was doing 2 plus 7 and getting 5 for some reason. That's why I paused. I was like, wait, that doesn't work. But it does, yeah. 3 minus 1 is 2, so this is my answer. Remember, if you're in doubt about which is your extraneous solution, remember that trick I showed you in your calculator where you could let this left side be y1 and this right side be y2? So this funky looking graph is going to run into the horizontal line at 2 just one time. And that spot is where x is 1. So you could always use your graphing calculator to support how many answers you're going to have and where they're at. That's a fun trick. All right. So, backing it up, you isolated, you eliminated, you solved, and then the last step is you check. We got one more, and then you get some practice. You can do it.
It's a minute, too.
You have a minute. It's pretty easy though, right? And this is a 2-day lesson, so we will continue tomorrow. But this one you would go ahead and cube both sides. Oh, less than a minute. So yeah, we didn't need to worry about isolating in this case. We can just jump right into eliminating that radical expression. And because this is a cube root, we would just cube both sides. So if I go ahead and cube both sides, I get 25x by itself. And then on the right side, I have, all right, cubing both sides, we get 125x cubed on the right side. To solve this particular equation, I would subtract 25x from both sides to get one side equal to 0. So I have 0 equals 125x to the third minus 25x. Now, unfortunately, at this point, those are not like terms, so I am going to try to solve this with factoring. I would just start by pulling out a greatest common factor. 25 and x goes into both of these terms. And then 25 times 5 would get us back to 125. X times x squared would get us the x cubed. And then minus 1 gets us back to the 25x. I then have to use my zero product property, like we talked about before, to get my answers for x. So I'm going to set 25x equal to 0. And I'll set 5x squared minus 1 equal to 0. Divide both sides by 25. Or you could just think to yourself, 25 times what gives you 0? Yeah, one of my answers here is 0. And for this, I would basically SADMET. So I'm going to add 1 to both sides. And we have 5x squared equals 1. I would then divide both sides by 5. I gotta get that x squared all by itself. So I have x squared equals 1/5. To get rid of your squared, you are going to square root both sides, which involves square rooting the top and square rooting the bottom. So we have x equals plus or minus your square root of 1, that's just 1. And then we have the square root of 5 on the bottom here. You might remember from earlier on in this chapter, you can't leave your square root of 5 down there, so we do have to rationalize. Multiply the top and bottom by your square root of 5. And we have plus or minus the square root of 5 over the square root of 25, which is 5, for our final answer. So 3 answers for that last problem. We have 0. We have the positive square root of 5 over 5. And the negative square root of 5 over 5. And all 3 of those actually work. So no extraneous solutions on that guy. I'm going to go ahead and give yourself a little bit of independent practice. I did that first one for you. Your answers will be on the next slide. Oh yes, and you can definitely skip that number 2. Here are your final answers. Here's hoping you met with some success in the first part of this lesson on solving radical equations.